Namaskar. In this video, I would like to demonstrate the simulation for the movement of North Celestial Pole through one complete cycle of the precession of equinoxes. Now, this one complete cycle for the precession of equinoxes, which is actually a cycle for one complete rotation for the point of North Celestial Pole, and that takes about 26,000 years. We will begin with the year 2100 CE, which is about 84 years in the future from today. And the reason I selected this date is because around 2100 CE, the point of North Celestial Pole would be closest to the star Polaris, which is our current pole star. For this simulation, I decided to focus on stars with magnitude between 0 and 4. Now, this scale for the magnitude of a star, which is for their brightness, kind of works counterintuitive. So please remember this. Smaller the number of magnitude, brighter the star as it would be seen from the Earth. Take for example Polaris. Let's note down its brightness. It's around 2. So it's somewhere halfway on our scale, or on my reference scale that I chose for this simulation, somewhere from 0 to 4. So it's not the brightest star. The brightest star would have lot less magnitude. Remember the counterintuitive nature of this scale. And in fact, star Abhijit or Brahmarashi or Vega is used as a reference point. So it has been assigned a magnitude of 0 or close to it, and then the rest of the stars and their magnitudes are mapped against that reference point. In any case, Polaris is indeed a distinct star. It can be seen easily in the night sky, clear sky, and with less light or dust pollution. We will begin with a step change of 5 years and go backward in time, and I will stop it anytime a distinct star shows up in the vicinity of this point of North Celestial Pole. So for example, around 1000 BC, and I'm going to round off the figures here, 965 BCE. If we look at Kochab, this would have been seen or perceived as a North Pole star. Let me move the information panel. Around 1000 BCE. If you look at declination, it's 83 degrees. Now the point of North Celestial Pole has a declination of 90 degree by definition. Okay, so Kochab is indeed close, and it would have been considered as a North Pole star around 1000 BC by the civilizations of that time. Its magnitude is 2, which is right in the middle of the scale. All right, so let's move on, and immediately we are going to arrive at another star, Thuban. This is around 3000 BC. So people and civilizations that existed around 3000 BC would have considered Thuban as their North Pole star. Its magnitude 3.65, so relatively faint star. Now keep in mind that magnitude is a crude scale. The actual brightness does get affected by many other factors, but we will not go into them because it is out of the scope for the discussion that we are doing here. Just note down 3.65 as the magnitude, and Thuban would have been considered as a North Pole star around 3000 BC. So let's continue our journey backwards in time. The next one I'm going to stop here is at Tau Herculis. So let's note down the time. It's around 7500 BCE, and the magnitude of Tau Herculis is 3.90, close to 4, again a faint star. So civilization around 7500 BCE would have considered Tau Herculis as their pole star. Let's continue our journey backwards in time. And we are going to arrive at Abhijit, Brahmarashi, or Vega as our pole star. The timing would be around 12,000 BCE. This is Vega, Abhijit, Brahmarashi, various names. And let's note down its magnitude. It's 0.07, and as I mentioned, the magnitude or the brightness of this star was used as a reference scale for this magnitude measurement by setting its brightness equal to 0 or close to it. All right, so civilization that existed around 12,000 BC would have considered Abhijit as their pole star. Next stop is at this star here. All right, let's quickly note down the magnitude. It's 2.92, so about 3, and the timing is that of 14,000 BCE. Also want to note down this other bright star here, Deneb. Forgive me. I pressed the wrong button. All right. I don't know why it is going backward and forward. Okay. Simulations can do that. Okay, let's see if it works this time. Oh, it did. All right. So around 16,000 BCE, civilization of that time would have considered Deneb as their pole star. Let's note down its magnitude is 1.33, and as you can see, it's pretty bright. And also note down the declination. It's 85 degree. In fact, I should have done that for Abhijit also. At its closest to the north celestial pole, Abhijit had attained a declination of around 86 degrees. In this case, Deneb around 85 degrees. And the timing of around 16,000 BCE. All right, let's go backwards. I will note down star here with brightness or magnitude of 3.67, and it had declination of around 84 degrees, and the timing is that of around 17,000 BCE. So this star might have been considered as a pole star by people and civilization of 17,000 BCE. Okay, if you go further back, we come close to another star, bright star, Alderamin. I'll stop it here. Let's note down the timing. So that's around 19,000 BCE. And let's note down the magnitude and declination. So magnitude is 2.50 and declination of around 85 degrees. Now keep in mind, this declination changes as the point of north celestial pole move closer or away from these astral bodies. All right, so about that 19,000 BCE, civilization of that time would have considered this star as their pole star. Another star coming up. Let's note down its magnitude 3.23, declination of around 85 degree Alfirk, and the timing is that of 21,000 BCE. So any civilization that existed around this time would have considered Alfirk, I don't know even how to say it, but this particular star as their pole star. All right, there's another bright star here and I want to note it down. Okay, so the timing is that of 22,000 BCE. It has magnitude of 3.37, declination at this time of around 86 degree, similar to what Abhijit attained when it was closest to the point of North Celestial Pole in around 12,000 BCE. So any civilization that existed around 22,000 BCE would have considered this star as their North Pole star. And we are going to complete our circle. So see, again, it's acting a little bit funny. Maybe I'm pressing it twice. All right, so timing is that of around 24,000 BCE. So recall that the complete cycle takes around 26,000 years. So 24,000 years of the BCE time frame, and then add to that approximately 2,000 years of the Common Era. So that adds up to around 26,000 years. Again, we have noted down the magnitude of Polaris before. It's 2. If you remember, when we started, it said 1.99. No difference, but my point is the magnitude can also get affected by a few things. But especially how bright a specific star is perceived from the Earth depends on not only magnitude but few additional factors. Even then, magnitude does serve as a useful indicator for the brightness of the star. All right, so that's our one complete cycle for the movement of North Celestial Pole. And as we went through this simulation, we noted down some of the bright stars on its path. We noted down their magnitude, and we also noted down the timeline, the time frame when these particular stars would have been considered as the North Pole stars in their times. Hope this is useful to you for multiple reasons. However, I created this specific video with a specific astronomy reference from Valmiki Ramayana, and that reference refers to Brahma Rashi or Abhijit or Vega as a pole star. The specific reference is that of Brahma Rashir Vishuddhasya Shuddhasya Paramarshaya Archishmantah Prakashante Dhruvam Sarve Pradakshinam. I hope you find this simulation useful in whatever astronomical research that you are working on. Namaskar.